distances on the map. All right, so first of all, in order for you to find the distance of the map, you will have to familiarize yourself with the scale of the map. All right, so the purpose of the scale of the map is to help you to find the ground distance. The scale compares the map distance with the ground distance, and it is expressed in three main ways. So when you get your map in your exam, I want you to look and see if you can identify the scale. Now, the scale might be expressed as a ratio, or we also call it representative fraction. It might be expressed as a statement, or it might be expressed as a line. All right, so number one on the screen that you're seeing, 1 to 20,000, that is our representative fraction. The statement scale, 1 centimeter to 3 kilometer, that is our that's our statement scale. And right there where you're seeing the line, that is our linear scale. All right, all three are showing map distance and ground distance. So for the ratio scale, the 1 is the map distance, the 20,000 is the ground distance. This type of scale doesn't normally have units. It would take the unit that is being used on the map. So whether it's in centimeters or in inches, if the distance being used on the map is in inches, then what this would mean is that 1 inch on the map represents 20,000 inches on the actual ground. If the distance being used on the map is centimeters, what that means is 1 centimeter on the map is equivalent to 20,000, or represents 20,000 centimeters on the actual ground. All right, so it just takes the distance that is being used on the map, the unit rather. Statement scale, as you can see there, shows 2 units. We know that centimeter is a smaller unit than kilometer. So the centimeter, the value being used at the centimeter is showing the map distance, which is always smaller. And the value being used at the kilometer is showing the ground distance. All right. For the linear scale, how do you identify the ground distance different from the map distance? Well, if you look from this point to this point, notice it says 1 kilometer. We know that this cannot be 1 kilometer in reality. So this 1 kilometer must represent the ground distance. And this space, whenever you measure it, let's say you measured it and you got, say, 3 centimeters, then that 3 centimeter would be the map distance. All right, so all of the scales are showing map distance and ground distance. And because these scales are showing map distance and ground distance, it's let me tell you what it is like. Just like in the on your map, you see a legend and you have a symbol and then you have the meaning of the symbol. It's the same kind of thing where you have the map unit, which is almost symbolic, a number that you're using that is symbolic of the real number. All right. All right, so you should be able to use any of these scales to find the ground distance on the map. All right, so let's look at some calculations that we have here. For the representative fraction or ratio scale, in this example, it says if the scale of a map is 1 to 50,000, what is the distance on the ground if the distance between two places on the map is 3 centimeters? So what we would simply do, remember, this part of the scale is a part that tells us the ground distance that is equivalent to the map distance. So what we're saying is if 1 unit on the map is equivalent to 50,000 of the very same unit on the actual ground, then 2 units on the map would be 100,000, which follows that 3 units on the map would be 150,000. Now you wouldn't have to do it this long way. All you would simply have to do is to multiply the distance that we are given, which is 3 centimeters, by this value here, this part of the scale. So it's 3 centimeters multiplied by 50,000, and that would give us 150,000 of this same unit, which is centimeters. But usually when we don't leave our answer in centimeters, all right? Centimeters, a small unit, we usually use it for the map distance, but not for the ground distance. So we can convert this 150,000 centimeters to kilometers, and we can simply do that by dividing 150,000 by 100,000. And the reason for that is that 100,000 centimeters give us 1 kilometer. All right. So what I would advise you to do is to study your units. Study your units and get comfortable with that so that you will be able to convert easily. All right. Now, if you are given the statement scale, and in this example, it says if the scale of a map is 1 centimeter to 3 kilometers, what is the ground distance of two places which is 2 centimeters apart on the map? All right. And again, if 1 centimeter is equivalent to 3 kilometers, then we know that 2 centimeters is equivalent to 6 kilometers. And 3 centimeters would be equivalent to 9. Sorry, this should be kilometers. Kilometers. So again, what we're doing in order to find the ground distance, we are multiplying the distance that we are given by the part of the scale that shows the ground distance, which is the 3 kilometers. And in this case, we wouldn't have to convert it to kilometers because it's already in kilometers. All right, so that is the statement scale. All right. So little calculations like these you might get in your multiple choice. All right. So here are some examples. You can pause and you can try to calculate these distances. The first one says, if the scale of the map is 1 to 25,000, what is the ground distance in kilometers of a river which is 3 centimeter on the map? Again, you would multiply 3 by 25,000. Whatever you get at the end, you would first have that answer in centimeter, then you would convert it to kilometers. The next one says, what is the actual distance of two places, which is 2 centimeters on the map, if the scale of the map is 1 to 10,000? So again, we would multiply the 2 centimeters by the 10,000. Number 3 says, if the scale of a map is 1 centimeter to 2 kilometers, this one is a statement scale, right? So the first two were ratio scales. This one is a statement scale. What is the ground distance of a road which is 3 centimeters on the map? So now we are going to multiply the 3 centimeters by the 2 kilometers, because remember the 2 kilometers, this is a part of the scale that is showing the ground distance. So you are multiplying this map distance by this ground distance. All right, and whatever you get, you would just keep it in kilometers. Then number 4 says, if the distance of a road on a map is 3 centimeters, the scale of the map is 1 to 100,000, and the change in height between the start and the end of the road is 150 meters. Calculate the gradient. So the end result is for you to calculate the gradient, but in order for you to calculate the gradient, you need to find the distance. So when you study or practice calculating the distance, it's not just for finding distance alone, but also to find the gradient. So for something like this, remember gradient is rise over run. We already have our rise. So we would have to calculate the run, which is the distance. And we would do that by multiplying the 3 centimeters by the 100,000. Remember, when we do that, the answer would be in centimeters. Now, remember, when we are calculating gradient, we need to have both values in the same unit. So when we get our answer in centimeter, we would just go ahead and convert that to meter, and then we would find our gradient. All right, so we take it one step at a time, and we won't have any problem. All right, now when it comes on to our linear scale, it's a little different. All right, so for your linear scale, you're going to need to use a straight edge paper. All right, and you're going to place the straight edge paper along the distance that you're asked to find, and after you're going to mark off those distances on the paper, and then you're going to place the paper against the line scale, and you're going to measure the distance. Now, students struggle with this for a number of reasons. All right, when it comes down to just finding a straight line distance, let's say you're finding a straight line distance from A to B, that is not as challenging for the student because you just simply place your paper from on the map and you line it up against the A and the B, you mark it off, and then you would place this against your linear scale. So this part is not so much of a challenge for most persons. But in other situations, you might be asked to find the distance from A to B, and it's not the straight line that you're being asked. You're being asked to find the curved distance. Again, you would use the straight edge paper and you would pivot the paper around. I'm going to go into it a little in a little bit more details afterwards. You would pivot the paper around and you would mark off all the little straights on the paper, and then you would take the paper again and place it on the scale. Now, that leads me to the other challenge that I find a number of students may have. Even when they get this part correct, the challenge is how to actually place the paper on the scale and how to read the scale. So I am going to look at that. Okay. All right. So this illustration is just showing the two different ways that you might find distance. You might be asked to find the straight line distance. So all you're going to do is place your paper against the 2 points and you mark off those 2 points. Or you might be asked to find the curved distance, which means that you're going to have to take your paper and you're going to have to move it around the curve. See, to ensure that you get all the different straights on the curve. You're marking them on your paper, and then you place the paper on the linear scale and you do your measurement. All right, so let's say that you have this map. You've been asked to find the distance from Penn to Sydney. You would have to get your straight edge paper and you would first find the first straight. So you're finding a series of straights. So you're going to find the first straight, line it up so that you can find the first straight. Then you're going to just use your pencil point to assist you. Just put your pencil at the end of that straight, and that is you are doing that to hold down the paper. Of course, you would have marked off the points, the starting point and the end point for the first straight. Use your pencil to hold down the paper, and then you would just shift the paper around, right? You would just shift it, pivot it a bit to get the next straight. Mark off the end of that straight. Again, use your pencil, pivot it around again to see if you can get the next straight, mark it off, and you would continue just like that until you are at your end point. I hope you understand. All right. So this is showing you what you would be doing. So this is how you would line it up for the first straight, and then you would find the other straight. So you'd have to turn your paper use your pencil, and what I would advise you to do when you are marking on your paper, I would also advise you to mark on the map as well, so that if the paper slips off, you can easily find back the point on the map where you last made your markings. All right, and so you would just pivot the paper around as you find the different straight areas along the curve until you are finished. Now, when you are finished, your paper is going to have some markings on it. What I would advise you to do is just to make the first marking a little longer than the rest, as well as the last marking. So you know that it is between these 2 points that you're going to do your reading on your scale. All right. So that takes me to the other challenge that some students have, simply because they don't understand how to read the scale. All right, so let's note a few things. A to B is the same distance or length as B to C and as C to D. That's the first thing I want you to understand. So even though A to B looks a little different and a different unit is being used, it is the same length. All right, so what this is showing us is that since B to C is 1 kilometer and A to B is 100,000 meter, it means that 1,000 meters. It means that 1,000 meters is the same as 1 kilometer. All right. From A to B, this part is broken down in fractions. So this 1,000 meter length is broken down into 10 segments or 10 parts. So if we have 1,000 and it's divided into 10 parts, 1,000 divided by 10 gives us 100 meters. So it means that each of these represents 100 meter. This is 100, this is another 100, this is another 100, this is another 100. Now, since this same distance, that is 1,000 meters, is the same as 1 kilometer, it means that this 1 kilometer is divided into 10 parts. So if we divide 1 kilometer by 10, we're going to get 0.1 kilometer. So what I want you to understand is that this length here is 100 meters, and it is the same as 0.1 kilometer. This length here is 200 meters, which is the same as 0.2 kilometers. And we could continue. This is 300 meters, which is the same as 0.3 kilometer. 400 meters, 0.4 kilometers, which means that when you're giving your distance, you need to be clear if you're going to be expressing it in kilometers or meters. If you're going to be expressing it in kilometers, then you would bear in mind that each of these divisions is 0.1 kilometers. If you're going to express it in meters, you have to bear in mind that each of these divisions is 100 meters. The biggest mistake you could make is if you are showing this length from this point to this point and you write 300 kilometers. It wouldn't be 300 kilometers, it would be 300 meters. Or it would equally be incorrect if you say 0.3 meters. All right, so you need to get that clear. All right, so that is one way that students also mess up a bit when they are finding the distance. All right, so let's say that you had measured a certain distance, whether it be a curved distance or a straight line distance, and now you are placing your straight edge paper against your linear scale. What I want you to remember is that you need to start at 0 all the time. So you put the starting point, the first little marking that you had done on the paper, place it so that it lines up with the 0. And again, another mistake that students make is that they place their paper like this, and they put their starting point over here, and then they measure in this direction. Now, this is going to give you a smaller length than the actual length if you do this. All right, so always remember to start at the 0. Okay. Now, sometimes when you mark off the length on the paper and you place it against the linear scale, you're going to find that it goes past the number, the ground distance value on the linear scale. So for example, for this distance from the factory to the government building, when you put it against the line scale, after you've marked off the 2 kilometer mark, you notice that this part is left over, all right? And it's not long enough to be a whole number in kilometer. So what you will need to do is to put it on the fractional part of the scale in order to find that distance. So let's say that this part that we have left over, we are placing it over here. Again, we are going to start at the 0, but we're measuring in this direction. So when we were measuring the whole number, we measured in this direction. When we're measuring the fractional part, we measure again from the 0. Sorry. Let me make my correction. Right, you're measuring from the 0, but you're measuring in this direction. All right, because the values would be increasing this way. All right, so for this full length, we already have 2 kilometers. And we want to measure this part of it. We place this part after we've marked off this, and we we've indicated that this part is 2 kilometers. We are measuring this part now. We place it against the fractional part of the scale, and we notice that it goes to about right here. All right. Now, notice it is not exactly, notice this would be 100 meters. This would be 200 meters. This would be 3. So it is closest to the 300 meters. So we'd keep it as 300 meters. And remember, 300 meters is the same as 0.3. So the total distance would be this 2 kilometers plus 0.3 kilometers. So it would be 2.3 kilometers. All right. That's our distance. All right. Let's look at this last one. Let's say we get this map and we're asked to find the gradient of the land from the school to the hotel. All right. First thing we have to do is to identify where the school is and where the hotel is. Then we have to ask ourselves, what is the formula for calculating the gradient of the map? And we know that the gradient of the map is rise, which is the same as height over run, which is distance. We're not given the distance, it means that we have to find the distance. When we think about finding the distance, the first thing we need to find on our map is the scale. So we see our scale right there, it's a linear scale. And we're going to use this linear scale to find the distance. Now, what if it wasn't a linear scale? What if it was a statement scale or a ratio scale? What would we do? We would, of course, get our paper. We would mark off these 2 points. On the paper. Then we would now have to use another instrument, which is our ruler. So we would take our ruler and we would measure this distance in centimeters, or usually in centimeters. And then now we would have our map distance in centimeters. And we would simply multiply that map distance by the either ratio scale or the statement scale. Okay? But in this case, we're using a linear scale. So once again, we take our paper, we place it on the map so that it lines up with the 2 points, and we mark off the 2 points. And then we place it on our scale, and we ensure that we start at 0. What we notice is that that length that we marked off exceeds the 2 kilometer. 2 kilometers. So we mark off the point where the 2 kilometers reach on the paper, and then we're going to take our paper because we need to find this part of it, this length. We're going to take our paper, and now we want to place it against the fractional part of the scale, all right, which I'm showing over here. So again, we're going to start at 0, but we're measuring in this direction. And when we do so, we notice that it is not exactly on the 9, but it's closest to the 9, to the 0.9, or the 900 meter. All right, so right here, that's about 900 meters or 0.9 kilometers. So remember, we had 2 kilometers already. So we're going to add that 2 kilometers with our 900 meters. If we want to express, because sometimes we're asked to express everything in meters. If we're asked to express everything in meters, then we would simply convert these 2 kilometers to meters, which would be 2,000 meters. So it would be 2,000 meters plus 900 meters, which would give us 2,900 meters. Or if we're asked to express it in kilometers, then we already have our 2 kilometers, and we know that this length is 0.9. And so when we add up, we get 2.9 kilometers. Now, avoid making the mistake of saying, for example, 900 kilometer. That's a mistake that student could make. To say that this is 900 kilometers, you have to be careful about doing that, okay? All right. So now that we have our distance, it is time for us to find our height. Now, how we would get our height, since this is 300 and this is 200, we would simply take the difference between the two. So 300 minus 200 gives us 100 meters. So our height is 100 meters. Our distance is 2,900 meters. And we would put our 100 over our 2,900 meters. We would divide 100 by itself because we're trying to get a 1 at the top. And what we do to the top, we do to the bottom. So we would also divide 2,900 meters by 100 meters, which would give us 29. So our gradient would be 1 to 29. And what this means is that for every 29 meters that we go across, we are going up by 1 meter. All right? Just in case you're asked to explain what this ratio actually means. Okay? I trust that you will find value in this video. You can always rewatch so that you will get the parts that you did not fully grasp on your first view of the video. But in order for this to stick, I would encourage you to find some past paper questions and do some practicing. All right? So all the best. right? So don't forget to like, to share, and to subscribe.